The objective of this video is to demonstrate how to perform an ANOVA experiment and determine if there is statistical difference or statistical significance between two treatment means. The problem we're going to use is this data set right here that has 3 different treatments, and the data is listed below. Our null hypothesis are equal, that's mu1 equals mu2 equals mu3, and the alternative hypothesis is that at least 2 of the means are different. So in order to start this, we're going to go to our data pack, and I'm going to hit single factor, and I've already plugged in the data, but I'm going to repeat it. I'm going to just hit the input. We have labels. We're going to test at alpha equals 0.5, and we're going to put our data right here. So I'm going to hit OK, and here is our data and specifically our ANOVA analysis. So step 1 is we're going to look at our p-value right here and see that it is indeed less than 0.5. Therefore, we will reject the null hypothesis and say that at least 2 of the means are different. So once we get to that point, now we're going to answer this question. We're going to use the Tukey method to compute the margin of error and then the confidence interval for the target parameter mu3 minus mu1. As stated before, we're going to assume an alpha or level of significance equal 0.05. So in order to calculate the margin of error, we're going to use this equation that we learned in class, and this equation represents the margin of error for the mu3 minus mu1 confidence interval. And so that equation uses this studentized range times the standard error divided by the square root of n sub t, where s, the square or the standard error of the mean, is equal to the square root of MSE, n sub t equals 5, which is the number of sample treatments. So the first thing we're going to do is we're going to go to our textbook, and we know that we have 3 different treatments. V is the degree of freedom that corresponds to the MSE term. Okay, so K is 3, V is 12. From the book, we get Q alpha equals 3.77. So in order to calculate the margin of error, we're going to set set Excel equal to 3.77 times S is the square root of MSE. So we're going to square root. MSE is this right here. And we're going to divide by the square root of n sub t, which is 5. Okay, so this becomes our margin of error. Okay, so once we have our margin of error, and we'll take some digits away, now we can calculate the lower and the upper bound. But first, what we need to do is, since we're calculating an interval for mu3 minus mu1, we have mu3 is this 7.42, goes with treatment 3. Treatment 1's mean is 3.64. So the difference equals 742, this cell, minus this cell. Okay, so this would be the difference. So to calculate the lower and upper interval, we simply will subtract and add this margin of error from this difference. And so we're going to hit equal 3.78 minus 2.35, and we're going to add the difference plus the margin of error, and this is the confidence interval for this ANOVA experiment. Again, this is the confidence interval for mu3 minus mu1. We've calculated the margin of error. It equals 2.35. And our confidence interval, the lower and the upper bound, spans between 1.43 and 6.13. That concludes this video.